I've had the privilege to have worked in various different teams, including assessments, LSCP, MindSpot, detailed assessment, and other sales marketing also. So yeah, I've learned from all the people, all the different teams. Currently, I'm working with the pedagogy research team on 2-3 key things. So one is it's a very small team that we have. Mainly 3 people working in the maths pedagogy area, Maulik and his team. Then we have Kirati and a team on the Gujarat Science of Learning Institute project. So it's a fairly small team. But yeah, we are looking at enhancing content in MindSpark based on data. So pedagogically, so say MindSpark, whatever content we have, it has been there for 10, 12 years now. So we're looking at enhancing MindSpark content further to make it pedagogically richer based on data. We are looking at foundational literacy and numeracy assessments and development. So developing tools to measure foundational literacy and numeracy skills, both physical as well as digital tools to measure. And on the science of learning side, working with the Gujarat government to see if we can get this entire movement around science of learning started at a state level, and looking forward to like even reaching out to other states. So in essence, yeah, I think it's been just slightly over 2 years in with the pedagogy research team. And the entire reason for forming pedagogy research team was to have a dedicated team who can look at this aspect of pedagogy, which earlier was very much integrated with whatever development work we were doing. And a lot of products that we developed, when we developed it, had this entire idea of like, we go deeper into a good question or a good content, understand how students are thinking, and integrate that into like the entire journey of the product and the experience for the child. We also realized that we were not that good at making the product stronger from a user experience perspective, or making it seamless for an end user like a teacher or a school or a student. And that's where we prioritize that in between. But we realize that, yeah, we also need to go back to our pedagogy, the core of all our work, and not lose focus over there. So that's where we said, let's have a dedicated team who doesn't have like that pressure of I have to deliver X number of papers to my client tomorrow, and that sort of thing. So the team goes deeper into the aspect of pedagogy and tries to enhance whatever products we have. So that's the core focus for the team. And on the side, yes, there are newer things like the foundational literacy numeracy, which earlier we haven't really done in the history of EI. So that's something new that we have ventured into, we've done. And the science of learning work. So that's briefly about me and the team and the work that we are doing. Ashna just asked a question, would you like questions at the end? Feel free to just interrupt whenever you have a question, otherwise I'll lose that flow and focus. So yeah, feel free to interrupt me. I'll just, I can take questions in between. Now, we have 50 minutes, and I had certain pre-read share. I understand that you may not have been able to go through all of them in detail, but so there are 2-3 different things, right? So one is the entire science of learning idea, what it is, and what we mean by science of learning at EI. That's one. Second, the foundational literacy numeracy part, which is what is that we did to develop the tools in the past, how did we collect the data, and what are we doing on the digital data collection, the SoL app, basically to measure foundational literacy numeracy skills. So these are 2 large areas, and of course the Gujarat Science of Learning work and the SoL, the website, the learning library and all. So there are 2-3 areas which I wanted to touch upon. But what I would like to do is I would like to prioritize based on some of the things that you are also more interested in, so that, and some of the things you may already have heard, say in other sessions or other people talk about. So I don't want to make it repetitive. And at the same time, let's make it a more like question answer. So it'll be better if you can share from your perspective, what are these 2-3 things, or what should we begin with? And I can start talking about that first, and then we can cover the other things.
I have a question.
Yeah.
So It's actually about the work that the pedagogy research team does. So when you say that we've used some 2 decades of data and like we've learned something from there, what would be the life cycle of a question? How does it make it to, how does it come to you and how does it go back to, if you could share that process a bit, that would help.
Yeah, sure. Should we start with that? Yeah. Cool. So, see, so earlier we had only one product, right? We started with Asset. EI started with Asset, and Asset was the flagship product. 2001 we started, and the focus was to get large number of students to do Asset, and we started collecting that sort of data. Large amount of data started coming in, and that's where we started looking at data and saying that, yeah, what are the sort of gaps that exist, or the kind of misconceptions which exist, which basically the data is pointing out, the questions are pointing out. Our focus was on, for the development team, it was the focus was to develop good questions. So on one side, we wanted to make better questions, but that was not possible without the data. So we started using the data on questions to say that this question is effective, this question is not effective, or this question is able to tell me that students are thinking in a certain way, this question is not able to tell me that. And we identified certain indicators which could tell us that, saying that, yeah, let's look at the most common wrong answer, or let's look at the biserial coefficient, or whatever it is. So there are certain indicators that we used to identify whether the question was good or not, whether it was working or not. And that was a continuous cycle. So when I joined, like, I was developing asset questions, and my role was to like make asset papers. So but to make that, I cannot just like create. So one was I'll create out of the blue, and like, yeah, I read up certain resources, I create a question. But the second source for me was looking at data, saying last time I asked this question, this was the data. Now how do I improve that based on that data? Right? So that became a continuous cycle, saying I ask a question, I look at the data, I improve that question further. And that became part of our process in a lot of different things. So the looking at data got integrated into the entire process. And over a period of time, then of course we added other products, like MindSpark came in, detailed assessment came in. But the base for a lot of these products became asset and the data. So there were a lot of learnings for us in terms of how students think, and how we can target certain gaps based on the asset data that we started looking at. And that's where products like MindSpark were born, saying that, yeah, we know now for a given topic which are the different misconceptions which exist, which are the different ways by which we can remediate those. And we started incorporating those in the product. So now what happens is, like, we have tons of data on, say, lakhs of questions that we have. And the same question may have been used in a private school setting, in a government school setting, in different vernacular mediums. So now when we look at data, it's not just like one question and the data on that from one population, but it's like from different sources where the data has come in. And that becomes even richer in terms of like what we say, saying that this is how students think, and whether students across different geographies, across different types of schools, do they think in a certain way or not. So I think as part of the process, it's like it's become like it happens subconsciously. When you say I want to look at a question, it's not I want to look at the question alone. If it has been asked in a test, please show me the data as well. So I look at the question along with the data always, and that's become, for a lot of, it's not just like this team, but like across all the teams, whoever is looking at questions, whoever is looking at content, this is how we have started functioning. So yeah.
And how do these data points make it to an entire body of knowledge called the science of learning?
Yeah. So, like I said, we started with asset, and a lot of data that got collected on asset gave us information about how students think, right? And that's where products like MindSpark were born. And what we've realized is, when we look at one question or a set of questions and the data, like the pencil length measurement question, which all of you are aware of, right? Or like the decimal comparison question, what we know is what are the different ways in which students think for that particular question or for that particular concept. Which means that if there is a concept, I know the kind of misconceptions that exist, and I can and that is whether it's for a private school or for government school, and I can even say that yeah, it is common across both the schools or only in seen in government school, that sort of thing. That is at a question level. What large scale data enabled was to even say it with a predictable frequency, right? To say that this misconception, I can guarantee that 20% students will think like this, or say 80% students will have this misconception. So what, at a question level, we have a micro level insight saying this is how students think on this particular question. These are the kind of finite misconceptions that exist. On the other side, large scale data helped us give a macro picture saying at a large scale, so many percentage students think this way, right? So and that's where we thought that there definitely exists a science of learning, underlying science of learning, if we can use these two things, which is a micro level insight like how students think on a question, and a macro level saying that at a system level what percentage of students will have this. If you're able to marry the two, we can actually predict saying that these are the kind of misconceptions which exist at my population level, and these are the kind of things that I need to target when I'm teaching. And that's where I think this entire medical analogy, and let me share that one or two slides which we have on the science of learning, and I think that will be useful. So I'm sure you would have seen some of these slides. So can you see the screen?
Yeah, I can see your screen.
Yeah. Um, yeah. So basically, what we mean by science of learning is that it's a hypothesis that we have, where we say that if you're able to use the micro level insights and the macro level findings, there definitely exists an underlying science of learning, which can really transform the way we've been like even teachers have been looking at improving student learning. Uh, Sorry, one second. So yeah. So this example, I don't know whether you've seen this particular thing, right? So if we Google right now saying that what percentage of people or what percentage of people worldwide have diabetes, we get a very concrete number like saying X percentage of people have diabetes. But at the same time, if we search saying what percentage of grade 5 students have this misconception or make this error, we don't get that sort of data, and all we get is a very like a random set of links which will lead us to different websites or advertisements and all. So what we believe science of learning can actually create is the kind of repository which medicine has been able to create in the past decade, sorry, not decade, but like a century, and create a similar repository for education where we are systematically able to list down all the skills which are important for students to learn and master, all the misconceptions which exist, and not just like a list which I come up on my own based on my intuition or my expertise, but which is backed by data, right? Because finally we should be able to say that what is the frequency at which I am able to find this, and whether whatever I find in my class, is it normal or abnormal, right? So for example, in medicine we have like for various different things we have a range of things, or a range very clearly defined saying that if your sugar level falls between this to this range, or if your systolic pressure is between this and this, it is normal, but above this is high, above below this is like low. Similarly, large scale data in education could help us do that, which is create a body of knowledge and say that at class 5, this misconception, if it is below X percentage, it is okay. But above this is not okay. Or saying that if your skill level is between this and this, it is okay. But if it is low, if it is lower than that, it is abnormal. And that's the kind of repository that we aim to create using science of learning. And that's where this entire idea of science of learning library that we have right now came up, saying that let's try and collect data on important skills. And to begin with, I think the science of learning library project that we have was funded by GIF, under the GIF larger project of MindSpark and other things that we did in the past 2 years. So it was funded by GIF, and where we said, we will go deeper into grades 1 to 4, just the two subjects on literacy and numeracy. And that's where somewhere, again, the foundation literacy, numeracy assessments also came in. So what we said is we'll go deep into that, and we will try and do this entire science of learning, what we aim to do, just for that two subjects, and this very narrow focus on the grades 1 to 4. One of the things which we realized, which medicine was able to do, in education we don't have, another key thing, is extremely high quality diagnostic tools. Right? Today, if in case of medicine, when I go to a doctor, if I tell him my symptoms, saying I'm facing this, he will recommend a certain tests, saying that please go and get this test done. He will not jump to remediation. He will not give a medicine directly, which we do in case of education. Right? My teacher will probably just teach me again or do something. In medicine, that's not the case. So he will prescribe a set of tests. Now I can go to any lab in the city or in another city or another state, another country. I can show that lab technician saying my doctor has recommended this test, and he will know what exactly to do. He will have a very standardized test to do, based on which he will give me a report. Now, that report I can take to my first doctor or any doctor, and they will be able to interpret it in the same way. So the entire process from the diagnostic tool to the data has been very standardized. And that's what we wanted to create in science of learning, saying that to measure a certain skill, I cannot say that I will measure it my way, you do it your way, and then I will compare the numbers. Then the numbers will not be comparable. So what we said is we need to come up with standardized diagnostic tools. And that's where we listed down certain important skills. We came up with diagnostic tools for each of those skills and even misconceptions. And those are the tools which we use to collect data. And the data that we collected then informed saying, yeah, X percentage of students are at this level on this particular skill, Y percentage have make this error misconception. That became a repository. And let's so I don't know whether you've got a chance to see that, but we can go through that portal. How many of you have seen the SoL portal? Yeah. So I'll quickly show a few things that I wanted to stress upon on that portal. You can see the screen, right?
We can see the presentation, not if you've changed the screen. You'll need to stop sharing and start sharing your entire screen again.
Yeah, one second. Yeah, now can you see it?
It's loading. Yeah, I can see.
Okay. Yeah. So this is the portal that we have, the Science of Learning Library. And yeah, you guys have seen this. So basically the maths and language sections are there. And for each subject, we have these skills, which are key pedagogical concepts, the misconceptions, the diagnostic assessment, and the teacher resources. Now, this is what I'm referring to, the diagnostic assessments, the standardized tools. For all the skills that we have listed down in the various topics, for each, we will have a diagnostic tool. Of course, here we have, for whatever deliverables that we had only 10 uploaded over here. But on our side, we definitely have for all the skills. So for each skill, a teacher can come to this portal and say that I want to measure whether my students can fluently recognize the number or not. They can download this tool, conduct the assessment. So the tool also has like steps that they need to do, what they need to record. And after that, the data that they get, they can compare with these numbers, saying my class 2 students, my count per minute, saying how many numbers can they recognize correctly per minute, right? So count correctly per minute. And I can say that, yeah, my students can do only 20 numbers correctly, whereas average is 26. And this is the way they can use this. And over a period of time, the idea is that this library, the more data we collect, this becomes even more robust. To say that, yeah, if tomorrow I have data from say lakhs of students from different states of India or even other countries, I can say that, yeah, this is, and you can actually drill down to a given state and see what that particular value is for a given state or for a given geography and all. So this was just an initial thing where we collected data from 3 states in India. So Himachal, Rajasthan, and Telangana. And, and we collected around 400 students per grade from each of the states. So overall, we have around 1,000, 1,200 students per grade data. So the idea is that we should be able to use this tools to collect even larger scale data and build this sort of library. Now, this is on the diagnostic assessments. And similarly, when we look at the misconceptions even here, what it tries to show is all the misconceptions which we find, and most common in case of addition of whole numbers, like topic wise, and the extent of that error class wise. So saying that, yeah, if uh, in case of say in multi-digit addition, students add from the left to right, right? And you can even see the sample questions. If I'm a teacher, I can see what I mean by that. So saying that 49 plus 32, my students will start by adding 4 and 3, which is 7, and then say 9 plus 2, 11, and they arrive at this. And this sort of error you can actually see over here, what percentage. So for example, in Himachal Pradesh, class 2, 10% make this error, but by class 3 and 4, it drops. But in Rajasthan, it was fairly high. So it even gives granular data for a given question at like a state level, at a geography level. And if I'm a teacher and if I'm coming to this portal, of course, these things are like important, but it doesn't tell me what I need to do next, right? So if I'm a teacher, I'm more interested in how do I solve this problem. That's where we have certain sections like this saying that for a teacher, I should be able to explain saying, why do students go wrong? What is it that they miss out because of which they make this common error? So there are sections which can help teachers to understand this error better, the remediation better. So like, for example, this section, it tells them how they can actually remediate the common error and the misconception. So the idea of the portal is to collect this, not just for like grades 1 to 4, but across topics, across classes, and make this library in a way. I mean, this portal is also public. So the idea is to build this library, make it public for everyone to use. And yeah, right now we are doing this assessment, but we can imagine, say tomorrow, say 3 or 4 states are doing this on their own. They can actually contribute data to this platform, and this can even be more powerful. So this is the science of learning portal that we had, and the kind of vision that we had of creating a body of knowledge, a repository around this, which people anywhere can use to understand which are the skills which are important, which are the misconceptions which exist, what standardized tools I can use, and the remedials, like what can the teachers do. So with this, I mean, this was the entire idea of science of learning, and this continues. I mean, it's so somewhere like the Gujarat work that we are doing is along the same vision, saying that at a state level, can I build a repository like this, where I use high quality assessment, and the data that comes back on those high quality assessment, I use to gather insights for teachers, right? So I have a good diagnostic tool with good questions. I have large scale data. Now, what do I do with that? I extract insights saying that, yeah, this is what I'm finding based on this data, and I create resources for my teachers at a state level. And that's where they can put this science of learning to practice. So science of learning on one side is this entire concept of marrying the micro, macro insights and coming up with this, building a knowledge repository like this. But how do you put that in practice? So that's why we are saying that once we have an ongoing assessment cycle and the data collection in place, we can create teacher resources based on the insights that are emerging from the data, and that can be passed on to the teachers, saying that, yeah, do this in your classroom differently, or remediate this misconception differently. And that's what we are trying to do in the case of Gujarat Science of Learning Institute project. So I'll pause over here in case there are more questions around, say, the SoL portal or the FLN, sorry, the science of learning piece. Yeah.
Yeah, I have two questions.
Yeah.
Um, so one is, are we the only people doing this kind of work?
The kind of work that the science of learning work,
On
right?
science of learning, yes.
Yeah. So the science of learning, the term, and I mean, in in other countries, they use it interchangeably for something else. So like, for example, in US, you will find departments of science of learning in certain universities, but the focus is very different over there. There, what they say is they use principles of neuroscience to understand certain things of how students learn. But they are more like saying based on neuroscience, I say that yeah, X amount of X hours of practice is needed to do something. So to use like the research on neuroscience to come up with certain findings like these. But a lot of the things that we have seen are not practically usable for the teachers to consume. So that's the difference, where we are saying that what we call science of learning, which probably very few people, and even in US with some of the institutions or even the researchers that we've interacted, there are very few that we have found who are doing something what we are trying to say, which is science of learning should aim to create output which is practically usable by the teachers at the end of the day. See, the goal of science of learning, and while we are saying that yeah, the science of learning should create a repository and all, at the end, what is that we want to do? We want to change the learning levels of students. We want to improve their learning levels, right? So whatever we do has to contribute to in that particular area. And that's why we are saying that whatever we do in science of learning should create something meaningful, usable by the teachers at the end of the day. It cannot be a theoretical science, which I do it for my own intellectual stimulation. So, right. So that's where we are saying that whatever we are doing over here has to produce results practically usable by the teachers. And that's where very few people worldwide are doing something like this.
Okay, thanks. That helps. And my second question was, you said that eventually when we have more large scale data, we would be able to like find out more insights, more misconceptions. And you also mentioned that these have to be high quality assessments. So until now, from what I understand, is that we've only found these insights from the assessments that we have conducted. But what are some other large scale assessments that would qualify for, the data would qualify for this research? Can I use NAS data for this or no?
Yeah, I think it's a good question. So from what I understood, you are asking, are there other large scale assessments whose data is comparable to our data? Right? And can I say that, yeah, NAS data, if I compare with this, what does it say? What does our data say? Somewhere, again, it comes back to the tool that we are using and whether it is standardized or not. And when we look at NAS or even ASR for that matter, right, a lot of data becomes not comparable, because the moment you see the tool, you realize that it's very different in many ways. So while ASR also measures foundational literacy, numeracy skills, the kind of tools that they may be using may be very different to the tools that we may be using. And that's where it's not like there are no assessments to which we can compare. For example, our foundational literacy, numeracy, the entire set of tools that we have made are based on international assessments like EGRA and EGMA, right? So EGRA is basically early grade reading assessment, and EGMA is early grade mathematics assessment. So those are standardized assessment, and our assessments that we have created are like probably say 90-95% matching those, even from the implementation perspective, right? So one is the tool itself, but how is it executed? So do I collect data differently in that case? So it matches a lot to those. And so the data that we collect can easily be compared to, say, an EGRA test that was done in, say, African countries, right? And I can say that, yeah, my oral reading fluency in India is, say, my students can read 30 words per minute in government schools, whereas in African countries, that number is whatever X, Y, Z, right? So there are certain tools, and at the end, it all boils down to whether the tool is comparable or not. If the test is comparable, if the execution, the way the data was collected was comparable, then definitely we can compare. And there are such assessments there.
Okay, thanks.
So are we leaving this data open source? Like, can anybody use this data from that we're collecting from the Science of Learning app?
Yes, so I think, see, this entire this portal that we have, the Science of Learning website that we have, that is public right now, and that was part of the deliverable with GIF, right? So whoever comes to this portal can definitely log into this, and whatever data we are collecting under the GIF project will be made public. right? So like the 3 states that we collected last year, or even Gujarat data that we may collect this year, or like under the Science of Learning Gujarat project. Of course, it's not happening because of COVID, but if that data we are collecting under GIF, we'll definitely put this up on this portal and it'll be public for anyone to come use it. For other like the SoL app data and all that we may collect, I think somewhere we'll have to take a call whether we want to make it public or not, and to what extent we make it public, right? So
Still, sorry, 1 second. It would help if you could just like differentiate the terminology, which is the portal, the app, the library, so that we are all on the same page about what each of those mean.
yeah, sure. So see, basically, there are, so okay, let's take a step back. So when we are saying science of learning is our own idea, right? Now science of learning was also funded by GIF. The project, Science of Learning project, was funded by GIF, and the objective there was to build a resource like the Science of Learning portal, and create tools for teachers, resources for teachers, and share data publicly. So the Science of Learning library, the portal that we have, and of course I'm using Science of Learning library over there, which is this website, that was funded by GIF. Now, Science of Learning app is just a digital tool to collect foundational literacy numeracy data, right? So when I say SoL app, it's basically just my diagnostic assessments on the app, right? Which will give me the data that your portal is finally showing, right? So there also I used an assessment to get that data, but that was all on pen and paper. Now that I've converted to a digital format, and that is my SoL app, right? So the data that I'm getting is again like what the portal is showing, but whether I will put that up or not is something that we will still decide, and saying that, yeah, to some extent we will still put it up because finally it is for public good, and to some extent, see, somewhere we'll have to get acceptance from a larger number of people also, right? So whether it is, say, state governments or CSRs or whoever is working in this sector, for them to adopt our idea of science of learning and what we mean by science of learning, it has to gain that acceptance. And that's where to some extent we'll have to make this public, we'll have to share it so that it gains momentum, it gets that acceptance that we want. And yeah, it's not like everything that we create will be made public at the same time, because it's also our IP beyond the point, especially data and the tools that we are creating. So for example, the FLN tools that we have, the foundational literacy numeracy diagnostic assessments, are also public. They were created for the first time with CSF, and CSF has planned to make it public, so they will be public. So the tools, the test, it will be public, anyone can use it. But we will definitely have a lot of data which we may finally not share it on this library, which we can say that, yeah, we will give you specific reports which no one else can, and that's where we will say that that's our IP, right? So to some extent we will make it public, not all, but whatever is collected under GIF, we have to make it public because of the contract and the deliverable that we had.
So the FLN tool that we made is the same one that's on the SoL app, or is it different?
Yes. Right now it's the same. There are additional things that certain additional tasks that we are adding to the app, but the fundamental, what we are measuring, the kind of questions and the fundamental tests are the same, right? And since we're talking about the SoL app and the FLN assessment, let me try to explain like why we even created the app. What was the need to create the app, right? So and like this entire foundational literacy numeracy assessment and what it tries to measure. So basically, again, foundational literacy numeracy assessment, first time it was funded by CSF. We said, let's build standardized diagnostic tools for in Indian context using international tests like EGRA and EGMA. So that was the objective, saying to create standardized tools comparable to international assessment, but for the Indian context, which is, say, Indian languages will be covered. It'll be more aligned to what Indian curriculum is, but at the same time, it's not like we just measure what the Indian curriculum is saying. So we have aspects which are important, but say Indian curriculum may not be stressing upon. For example, say fluency, right? So for example, can students read words fluently or not? Like the oral reading fluency and all. No textbook, no curriculum in India, not even NCF stresses upon the fact that students have to develop fluency in things like reading or number recognition or addition facts, subtraction facts. But these are all internationally very common. It's like everyone measures it when it comes to foundational literacy numeracy. So those are kind of skills which we have also incorporated because we strongly believe in those, while curriculum may not be. So those are part of our assessment. So when we created those tools, and the same we use for data collection, even for GIF data for classes 1 to 4, what we found was that it was a very manual intensive process, right? So first of all these foundational literacy numeracy assessments, even EGRA, EGMA, are conducted in a very specific manner where I have a tool. I sit in front of the child and I spend 20 to 30 minutes just with one child, asking him questions orally. The child is giving me responses orally. And I have a sheet of paper, I write 10, whatever the details that I need to capture. And that was a very manual intensive process where first I need to find people who can do that, right? Because it's not like I can send anyone, go collect data and come, because the person has to be able to interact with the child in a certain way, has to be sensitive enough to realize when to slow down, when to increase the pace, be patient enough. I'm doing 20-30 minutes with one child, class 1 child, and then I have to do back-to-back assessments for my entire day. I have to do 10 students, so I have to be extremely patient. So this was not easy. So first I have to find these people, I have to train these people, and then comes the problem of standardization. I have 30 people going to the field. I want everyone to say the same thing. So let me just share. I think this is also interesting. Yeah, I'll just share some of the tools that we had and like what we did. Just let me know if you can see the screen.
I can see it.
Yeah. You see it, right? So for example, there are 3 tabs open. I'll take you through that. So this is basically something called the stimulus sheet, which is what the child will see, right? This is a class 3 assessment for foundational literacy and numeracy. It's a Sankhya Pehchan, which is number recognition. So first I show the child saying, if I'm conducting this evaluation, I show the child for practice this number and say which number is this, and the child will say 10. So this is just practice. And then I show these 10 numbers and the child will read from left to right. Right. And similarly, then there are other tasks like they have to write some numbers, or they have to compare numbers, saying which number is bigger, 2 or 1. And for each of those, they have to point out saying this is bigger, right? And similarly for all the different skills that I'm measuring. Now, this is what the child is seeing. What am I doing at the same time? I have a very standardized script like this, right? So, and no one can change this. So if I'm an evaluator, I have to stick to this. I have to say this. मेरा नाम निश्चल है, मैं एक शैक्षणिक संस्था में whatever, etc., etc. Everyone, 30 people going to the field will be saying this. When it comes to number recognition, they have to say this, they have to do this. So for example, they will say number recognition, the practice task, they will say, they have to point at the number 10 and say, ye kaun si sankhya hai? And then the child says, if the child says 10 correct, then what they will say? If the child says incorrect, what will they say? Now this is extremely standardized, but it's at the same time, it's also painful for whoever is conducting also, right? Because they have to repeat this again and again. It's like a thing that I read out almost. And while I'm doing this, so one, the child is seeing that stimulus sheet, I'm following this script, and at the same time, I also have to, sorry, how do I move this thing? Yeah. At the same time, I also have to record what the child is doing, which is so number recognition. What did the child say for 7? Did he say correct or incorrect? Correct is 1, 0 is incorrect. I have to record this also. So I'm like multitasking. So finding these people is not easy, right? And that's again, like somewhere the data has to be reliable, right? My data that I'm getting, finally, I should be able to say with confidence that, yeah, this is correct. International assessments like foundational literacy numeracy, one of the things that they do is something called inter-rater comparability. So if I have this assessment, let's say I am the evaluator and there is a child, if I do this and I collect data and someone else does the assessment and collects the data, do the 2 data points match or not? And to what extent do they match? So it's very manual intensive, this entire process. And that's where we said that the digital platform can help a lot in this. especially to standardize this, right? And also the turnaround time. Like imagine this person is doing everything manually. He's recording everything on the paper. It comes back, goes to the data entry person, and they have to then enter the entire thing. Also, some of the details we may not be able to. So for example, there are certain tasks which are timed, right? The number recognition, fluency, and all, where I also have to write down how much time was left and all. Now, we rely on the expertise of the evaluator to start the timer on, like when the task starts, stop it correctly, record this correctly. All this can easily be done on the app, and that's where we said let's convert all these assessment to the digital format. And so the SOL app basically does the same thing which this assessment was doing, but on the app format, where there is I'll just take you through few screens, and some of you may have seen this also. Uh, how many of you have seen the app? I think Ashish definitely has, but have others seen this app?
No, no,
No.
haven't seen that.
Okay,
No.
yeah. So yeah, basically all those kind of examples that we saw, right, which is number comparison, which is which number is bigger, or say number recognition, missing numbers, letter recognition, word recognition, all this we have converted to the digital app format. uh, the unique part about this app is that it also captures audio in, like whatever the child is saying, and it brings back the audio file for me. And that's very powerful because I can actually use that to understand how students read, how students say certain numbers. So these are just certain screens of the different tasks that we have. And it measures all the skills that I was measuring on pen and paper also, right? So for literacy, these are the different skills like oral vocabulary, listening comprehension, sound recognition, letter recognition, word recognition, ORF, etc. And numeracy, these are the different, all the arithmetic and counting skills that I measured. So it's just the same tool, pen and paper, whatever I was doing, it's a digital format. And just a quick,
Nishchal,
yeah.
which other organizations nationally or internationally are doing this? I mean, I believe a lot of organizations are using the Agragma tool, that is for one, but which are using it digitally?
Digitally, they have started doing it now. So like we are hearing for ORF, especially, like Google is coming up with something. But a tool like this, extensive, with a child is expected to do this, no one else is doing it. So in a way, whatever we have studied, there are these learning apps for children where some of these are done. But and a standardized assessment where the child does it, we haven't seen. So this is in a way like a first time someone is attempting this. And that's where what we are doing right now is like going to the field to understand whether students can do this or not on the app, and trying to master that. Like, okay, this doesn't work. The child, this is not intuitive. Let's make it intuitive. So that's something that we are doing. So, for example, on the left side, what the video that you are seeing is basically what the evaluator does for the first time, where they go to a school, and certain schools are assigned. If in case that is not assigned, they can actually create a new school and add a student. So in a certain class, they can add a student, enter the names, details, all the details that we are capturing on the pen and paper front, including socio-economic background, even that we are capturing here. So yeah, and this is just the first part. And second, what happens is basically like the actual assessment, right? So we quickly see. So the other unique part is, like, because I want to standardize the instruction, right? There I had a script. I have converted all that to my voiceovers. So for each task, there is a certain voiceover which plays, which the child can replay on the left top that you see this button, play button. It gives the instruction in a standardized manner for each and every task. So all the screens will have a voiceover. There are certain tasks where the child can input, like this number comparison, they have to tap, but certain things, the audio gets captured. And for different, for maths, it's a lot of it is like they have to type in numbers and all, but for the language part, a lot of it is like through audio capturing and all.
So Nishchal,
Yeah,
since you have a lot of voice, like the files of voice of children of
yeah,
in terms of vocabulary, right? So how do
yeah.
you assess all of it? Do you individually go through all of them and try to understand where exactly children is lacking, or like how does it happen? What is the
Yeah.
process of analyzing that?
Yeah, I think it's a good point. So all the places where there are audio files have to be finally evaluated by someone. And for the maths what we are seeing, those are recorded automatically. But let me show you, for example, yeah, this part, right? So the top screen that you see, once the data has come in, like say I go and do the assessment and I sync the data. Of course, so one of the other parts of the app is that it can work offline also. So I don't need to have internet. So I can go to the remote part of India. I can conduct this assessment offline, and I can come back whenever I have internet. I can sync the data back, and it uploads all the audio files. So then I will have people who can go through these audio files. And for example, here it says Sankhya Pehchan, and it reads the numbers, and I can play the audio file, listen to it, and I can mark saying, yeah, this was read correctly, this was read correctly, this was skipped, or this the child did not even reach. So there's an evaluation page like this. So certain tasks are marked correctly on their own automatically, and certain things I have to listen to the audio file and mark it. I'll just play an audio file and I don't know whether you can hear it. Just let me know if you can hear it. This is not number recognition. This is letter recognition, but I'll still play this. Sorry. Yeah. Just let me know if you can hear this audio. Can you hear the audio?
It's very low. Can't hear it clearly.
Okay. So let me play. Yeah. Yeah. So I don't know whether you're able to hear it, but yeah, basically what it was doing was, so the child was reading the words that were given. And what was interesting was, of course, that we can mark it correct, incorrect, but the other like nuances of how children read, like the child was reading the word, the word was say naman, the child was reading na ma na naman, chak chak. So whereas what we expect students to do is read and identify that word as a single word and not break it into letters and read, right? So, and that's where the fluency will play a role also. But when we heard this audio, we understood that, yeah, the child is not really reading it that way. So while the child at the end is reading Naman, the way the child was reading was not the way we expected the child to read. So these nuances, it's difficult to capture in pen and paper format. And that's where this app can be very powerful to capture such pedagogical nuances, right? Whether it is about reading letters or whether it is about like even arithmetic operations, like the 49 plus 32 example that we saw, left to right. Either I have to tell my evaluator to look at each and every problem that the student is doing and mark it, whether the child saw left to right or whether he did something else. But my app can actually record each and every step of my child. Saying the child first tapped on this button, the child tapped on this particular cell, then he entered this digit, then he entered this digit, then he entered this digit. And the telemetric data can help me gain these sort of pedagogical nuances and insights. So that's where this app can become very powerful to not just like do this assessment, capture data. Of course, that's something that is expected out of the app, basic thing. But in addition to that, it can also capture some of these nuances very well, pedagogical nuances.
So Nishchal,
Yeah.
So Nishchal, while some features are built to like auto capture the child movement and how the child is responding, the recording piece is something that still looks manual intensive, where somebody at the back end will have to listen and probably record according to some parameter that you have set.
Yeah.
So like what is like the approximate percentage of questions for a grade 1, 2, 3? I mean, how does an assessment look like? And what is like the percentage of say audio question or a video question, or I mean the basic larger categories of questions?
Yeah. So in maths, 90%, 95%, except this number recognition, everything is like they have to just input, where I have to tap a number or tap certain digits or select something. In maths, 90-95% of the tasks are where it gets captured automatically. Number recognition is the only one where it is audio file. It's opposite in language. So in language, 90-95% of the tasks are such that I have to capture the audio. And there are very few tasks where I have to tap, like say, for example, the sound discrimination, where I give you 3 words and you have to tell me which started with a different sound, right? So say chuck ghar and something else, chaman, and I can say, yeah, ghar started with a different sound. There I have to tap. So it's opposite in language and maths. So language is where you have to have someone who can sit and listen to this and mark these responses right now. Whereas in maths, it is opposite.
Do we have like a time duration in which the child should be able to do, or ideally be able to do?
Yeah, a lot of these assessments. So there are subtasks where it is timed, but overall we don't put pressure on the child to say you have to finish it in 40 minutes. We give as much time as the child needs. So there are some students who finish it in like 15, 20 minutes. There are some students who probably take even more. What we have is certain intelligent things in the app, and even in the one-to-one assessment, we used to do it to say that we identify whether the child is able to do that particular task correctly or not, and we should be able to stop it, saying that, yeah, now no need to do this, or no need to continue this. We understand that you don't know, so we'll stop. I mean, we don't tell that, but we have certain stop rules to say that let's stop the assessment now because the child is not able to do it. Or if we say that, yeah, addition nahi aata hai, so there's no point in giving subtraction, multiplication, division, and all, right? So we have these stop rules built into the app, which does not penalize the child, and in case he doesn't know. But otherwise, we don't put any time pressure. There are only these specific tasks like fluency, where I'm saying that how many can you read in a minute? I want to capture that. So that's where I say that I will stop the task after 1 minute. But otherwise, there is no time pressure for the child.
Okay. So, Nishchal, regarding the app,
Yeah.
so we are definitely trying to see that if the children can do themselves and on their own, and that will help in scaling a lot and a lot of other things that we want from this entire effort. Now, one thing, while you were comparing the earlier paper-based test and with the app, so there the another role of the facilitator was also to evaluate on the go, kind of like through filling that evaluation sheet. And so I was thinking, like, maybe in as an intermediary step, like what we are doing in the field trials now, can we have a separate app for the facilitator, like what we are trying to do with capturing the recording of the children through, where they can do some of the efforts that is going back end in putting. And the other aspect I was just thinking, for very small kids, like kids age 3 to 4, let's say, or 3 to 5, uh, and many of the students that we are dealing with who have very limited digital access, how is that going to impact, like, the performance of the child, or who have not seen a mobile phone or a digital device vis-a-vis a paper based? And with that aspect, the facilitator having access to a, a device where they can capture what is going with the children, and the app can work in two ways. One, the children can do on their own. Another way, just to display things, to make things faster. uh, is it is it possible to check that also as a step in between, just to?
Yeah, I think we can do some of those experiments, and for that, like the kind of tool that you are describing, which is my child is just seeing it on a, like, whether it is paper or digital.
Yeah.
The child is seeing, but I am the one who's capturing. But earlier I was doing it on paper. Now I'm filling it on
Right.
a platform.
Yeah.
So those sort of tools are already there. And where this tool differs is like those nuances which we wanted to capture.
Right.
And of course, at the same time, saying that, yeah, based on certain other things that we have seen, we believe that it is possible for children to pick this up, this skill of say using the mobile phone. And some of the features that we want to build, which of course right now are not there. So for example, like the audio files or the practice tasks that we are keeping, we want to have those videos, tutorial videos for each task to show what the child has to do.
Right.
Now, we believe that if certain things like that are shown to the child, and yes, maybe grade 1, even in addition to that, we may have to do something differently. But probably grade 2 onwards, given the, like, to some exposure that they have to this digital platforms and the, like, mobile devices and all, and going forward, it's just going to improve.
Right.
So what we want to do is, like, first thing that we want to attempt is this, creating a tool which they can use themselves. Creating the other one is fairly simple. It's a data entry platform that I need to create for someone. So that's where, and yes, I'm not saying that we don't need to do it. Those are experiments we need to do. And in fact, like, one of the things which we want to do, so once, like, for example, your team, whatever Ashish, your team is doing, once we have some initial reaction and saying that, yeah, these are some of the like a major thing we want to master on the app front.
Right.
Even after that, once we have which we feel confident that yes, this app is working, one of the things which we want to experiment is, let's say we take 200 students who are using the app, and maybe after a certain period of time we give them the pen and paper assessment. So if we do this same assessment on the child in the two formats, digital and pen and paper, how does the data compare? Is it like matching or how different it is? And that's where I think some of these experiments we'll have to do to confidently say the app works for any child or of any age.
Yeah. And the second question was like, yeah, you're right. Like earlier, for last couple of years, I was trying to read through the science of learning. I wasn't aware of the name because at college we were thinking of epistemological study of how learning happens and everything and all those. And definitely it's a lot to do with the cognitive science and the behavior of the and they are, I would say that we are trying to focus on the adaptive research of it, or more sort of like how do we take it on ground. But some of the learnings over the last I would say decade or so, they have also broken it down into many small pedagogical, and many like books have come which are like kind of preaching teachers what to do in classes, small like small teaching and other books also. So is there an attempt to also pick up from some of the learnings from them? And because we have a huge data source, and to some extent we would like to develop a team or like a which can capture also data very well, which they have very limited capacity. Like there is a very small laboratory either in the like a neuroscience department or something like that. And can we pick some of the learnings from there and say that, okay, we'll experiment this with 10,000 kids and let's see what is happening. And these 5 things that you that research have told us that should be tried and how it is. Because currently what we are doing is the bottoms up approach, that okay, from the data from various initiatives, that what are the learnings or the macro level pictures that we are gaining, and they can counter us to some extent that this is still a very like limited, like you are narrowing your scope. uh, it's a different exercise altogether. For them, science of learning is more to understand how things happen, and for us it's more what is happening and what to be done if that is happening. So like just trying to marry that, the two part, and like I was just thinking how to
No, I think so. On one side, this entire effort of creating this sort of repository using large-scale data on specific things and using data to say, yes, this is a skill to measure, or this is not an important skill to measure, or this is an actual error which exists, this is not an error which exists. So data to in a way inform us what is important, what is not, and what to prioritize, what to not. But at the same time, like the kind of enhancements we make in our product, right? So for example, let's say we already have a module in MindSpark to teach fractions, and our data is saying it is not effective. Now, how do I improve it? So to do that, the team has to look at some of these, what you're saying that, yeah, somebody has already done this research. Let's say decimal comparison, the entire DCT, the module that we have now, which is replica of a research done by Australian researchers. So there we go and say that, yeah, that researcher did it. They said it was effective. Can I use that? So in some of the learning interventions, I try to do that, which is, yeah, somebody's done it. Let me learn from that. Let me put it in my product and see whether it is working or not. But the other difference that we see is this entire saying that right now, the way a lot of teachers or a lot of educationists also work is saying that I have a theory. This is how students learn, and I'm experimenting it on my set of students. And then somebody else may have a different theory and they work on a different set of students. But what we tend to believe is that there is an underlying science of learning, like there is an underlying science of medicine, which is common to learning. And that is something that is yet to be discovered. And yeah, I think this is probably also the kind of state in which medicine was 100 years back, where each doctor believed that this medicine works and was experimenting, and something worked, something didn't work. But over a period of time, they realized that, yeah, there is an underlying science, and this is how we can build better remediation. So, yeah. We have crossed 12 p.m., but yeah, if there are questions, we can definitely discuss. Cool. If there are no questions, then yeah, but feel free to reach out to me on any of these points, whether it is FL and science of learning, in case you want to discuss further, or in case, say, you are getting questions from somewhere else where you may want to clarify. So definitely feel free to reach out to me at any point.
Thanks a lot, Mr. for. Sorry, was that a question? Soumya,
No,
were
no, I
you?
was just saying, sure, Nishchal, we'll reach out.
Yeah, cool.
Thank you, Nishchal.
Okay, thanks everyone.
Thanks,
Yeah.
Nishchal.
Thank you. Bye.
Thank you. Bye.